EL. So today we will describe about the UDP, that is User Datagram Protocol. Okay, so we knew about TCP, IP and the OSI model. We knew that. So UDP means this is a protocol, that is User Datagram Protocol. Okay, so this is used as another transport layer protocol actually. So UDP provides an unreliable datagram service. Okay, that means UDP, that is User Datagram Protocols, it is not reliable. Okay, so that means reliable means what? That means if the see the points, if the packets may be lost or delivered out of order, that means the packets what you are sending to the receiver, that one thing is you can remember that in transport layer all the data can be divided into different segments. Okay, so in that case the order of those segments can be disorder, or it can be the packets what are sending that can be lost. Okay, that you cannot rely on the, this is not reliable. Okay, so you cannot means you don't have any facility that to make understand that whether the packets is actually received or not. Okay, so the packets may be lost and delivered out of order, and users exchange datagrams, that means not streams. Here users exchange datagrams. Okay, they are passing the datagrams. Okay, and this is connectionless, that means no connections established between sender and receiver. So this is connectionless, and there is not buffered, that means UDP accepts data and transmit immediately, that means no buffering before transmissions. That means there is no memory, the data is not stored anywhere. Okay, buffered means what? Buffer means this is a temporary memory space which can use for at the time of processing. Okay, so if buffered is not here, that means whatever the data, whatever the packets UDP accepts, and it can transmits immediately. Whatever the things UDP accepts, that can transmits immediately. So no buffering before transmissions. So there is no, that means the data is data cannot stored here. So it just data cannot stored in any memory space. When it accepts the data, it immediately transmits those data. Okay, so next point, this is a full duplex method, that means concurrent transfers can take place in both directions. This is full duplex method. So all of you know that full duplex means the communications can be done between two devices at a time. Okay, that means sender can send the data to the receiver, and receiver can also receive the data, and but they can do it at the same time. So this is a full duplex method. So that means what are the points? That means UDP, this is the user datagram protocols. So this is another transport layer protocol, and this is the first thing. The second thing is UDP provides an unreliable datagram service. It provides an unreliable datagram service, that means the data what are providing, what are passing from sender to receiver, that is not reliable. You cannot rely that whether data is received by the receiver properly or not. So this is unreliable, and that means there are no acknowledgement system from receiver end to sender end. Okay, that means yes, I got it, I receive your message. So this type of things is not there. Okay, so if this type of things is not there, then the sender can't understand that whether the data is actually received or not. Okay, so that's why this is unreliable. And the things is that it passes datagrams, not streams. Datagrams, that is a special package, it is passing from sender to receiver. And then the next point, this is a connectionless, that means no communications is established between sender and receiver. Okay, so the sender can take the data and it send to the receiver. So this is connectionless, that's why no acknowledgement procedure is here, and there is no temporary memory for buffering purpose. So whenever the data accepts by the user datagram protocol UDP, they transmits it immediately, and this is a full duplex method. That means concurrent transfers can take place in both directions. Next, UDP datagram format. See, this is the datagram format. Datagram format is quite different. So here we have, this is a 32-bit datagram from 0 to 31. That means the datagram size of datagram is 32-bit. Okay, and here we have source port. That means port number is very important. This is a transport layer. This is for transport layer. So we need to communicate with process to process. Okay, so this is a process to process delivery actually. So we need a port address. Okay, so source port and destination port, these two addresses should be there. And message length of the message, what is the actual length of the message, that must be mentioned there. And checksum. Okay, checksum is for any type of error detections and corrections. This field is responsible for that. Okay, so this is the header part. So this is the additional informations what datagram should have. So this is the additional information, and after that there is data. Okay, that is the actual data. So we have the data, and before passing those data we need to have this type of informations in the header part. So this is the datagram format. You should remember that what a datagram can store. So there is a source port, destination port, message length, checksum. These are the header part, and after that we have a data part, that is the original message. Okay, so next, UDP header fields. So UDP destinations force. What is the purpose of this port? That is identify the destination process. Okay, so remember that this is a transport layer protocol. UDP is a transport layer protocol, so we have to communicate between the processes. Okay, not the host to host delivery, this is process to process delivery. So UDP destination ports, that is identify destination process. And UDP source port, this is optional. This identifies source process for replies or 0. It can be 0 because source port is it is a optional field. It should have or it should not have. It cannot have or you should have or not. So if you don't have source port, then means source port is there. If you are not mentioning the source port, then this is 0. And message length of the datagram in bytes, and it includes header and data. Okay, so this is the message length. And checksum, this is optional. This is 16-bit checksum over header and data. Okay, so or it is or it can be 0 also. If you are not producing the checksum, then it will be 0. So this is the UDP header parts. That means at the header part we have 4 fields. That means the source and destinations, you should remember like this, the source address and destination address would be there. So what are those address? That is the port address. As because this is process to process delivery, then we should have a port address. Okay, and then the message length, that means how long the bits are, that so that should be mentioned. So this is the message length, the length of datagram in bytes, including header and data. And then checksum also optional part. So we have 2 optional part, that is UDP source port and checksum. These 2 parts is optional. Okay, so checksum is a 16-bit checksum over header, and it can be a data or this is a header part over the means header. You should put the checksum, or it can be 0. So this is for header part. Now you have to know the difference between UDP and TCP. TCP is what? TCP means transmission control protocol. So choice of UDP versus TCP is based on functionality and performance. Okay, So performance TCP's window based flow control scheme leads to bursty bulk transfers, not rate based. That means here TCP can send the data as a bulk. Okay, so bulk data can pass. So that is the first thing, that you can pass the bulk data, and and then TCP's slow start algorithm can reduce throughput. Okay, slow start algorithm means data can be passed from source to destination slowly. Okay, slowly they can start to transmit those data, so it reduces the throughput. Okay, and TCP has extra overhead per segment. When TCP sends the data, it has the extra overhead. Overhead is there because we need a header part, and that must be much more informative in the header part, so it will be overheaded. So per segment there is overhead. But in case of UDP, it can send small efficient datagrams. So UDP can send small datagrams efficiently. Okay, so according to the performance, that is the difference. That's TCP window based flow control scheme. This leads to a bursty bulk transfers, but UDP can send a small datagram, and it is much more efficient than TCP. See, is the timeline we are sending the the datagrams. Okay. Next, reliability. So there is a difference. We have the difference between reliability also. So reliability means how much reliable your system is. So reliability can measure that whether the packet can say received by the receiver properly or not. So that is the reliability. So TCP provides reliable in order transfers. TCP provides reliability in order transfers, and UDP provides unreliable service applications, and it must accept or deal with packet loss due to overflows and errors and out of order datagrams. So at the with respect to the reliability, TCP provides reliable. TCP is much more reliable than UDP. So the difference between UDP and TCP is very important in your curriculum. So you have to remember that. So you have to judge the performance of the UDP and TCP at first. So according to the performance, UDP is better. Okay, because TCP can send the bulk data. Okay, there is no transfer rate. Okay, transfer rate means how many bits can send per second, that is the transfer rate. There is no transfer rate, and this is a slow start algorithm, so it can reduce throughput. Okay, and TCP has extra overhead per segment, but UDP it is a small means it has the datagram which is small, and it can send efficiently. Next, reliability. According to the reliability, TCP provides reliable. Okay, but UDP is unreliable. So because the applications must accept or deal with packet loss due to overflows and errors, and the datagram can be out of order. Okay, that is the multicast and broadcast. So multicast and broadcasting, this is supported only by UDP. Okay, so UDP can support multicast as well as broadcast also, but TCP, in case of TCP's error control scheme does not lend itself to reliable multicast. So multicasting is not happened there. So TCP's error control scheme does not lend itself to reliable multicast, so multicast is not possible here. Okay, so that is the difference between UDP and TCP. Next, data size. UDP datagrams limited to IP MTU, that is 64 KB. Okay, that means there is the data size is, the data length is high, 64 KB. Data size, this is the data size. Next, number 3, that is the application complexity. So applications complexity means what? That is, application level framing can be difficult using TCP because of the Nagel algorithm. Okay, so application level framing is also difficult for TCP because TCP follows the Nagel algorithm, and Nagel algorithm controls when TCP segments are sent to use IP datagrams efficiently. So when you are sending the data efficiently, then only this algorithm can control the TCP segments. But data may be received and read by applications in different units than how it was sent. Okay, so here data can be received and it can be read by the applications in different units than how it was sent. Okay, suppose it is sending in different pattern, and it can read in some other way. So it is depending on the applications what is present at the receiver end. Okay, so this is the applications complexity. So we can write the data in this manner. See, this is the writing pattern. We can write the data in this manner, but the reading pattern can be different. Okay, so written, so this is the two things. So there are complexity in case of TCP, application complexity we have in case of TCP, but in case of UDP we have this is the complexity is very less, because this is received the data and the data can be read in different manner also. So this is the diagram for user datagram protocol. You can write the data in some way and the data can be read in some different way. Okay, so this is the thing. So this is the third point of the difference between UDP and TCP. Now this is the fourth point. Now, which is used for? That is hypertext transfer protocol, file transfer protocol, or telnet, post office protocol. So these are the different application protocol. Okay, so here things is that you have to decide which protocol is actually using here. Okay, this that means when you are transferring any file, then that must follow some particular applications protocol. Okay, so it may be HTTP, it may be FTP, or it can be telnet, post office service, RWHO, remote who, okay, MBON, audio video real player, network file system, NFS. So there can be anything. See this model. This is a middleware model. So here you can see the applications layer, and then after that we have transport and network, then data link layer and physical layer. So the left hand side, this is for TCP. TCP IP has these 5 layers, that is application layer, transport layer, network layer, and data link layer, then physical layer. Okay, so application layers, that is the same as OSI model what you have studied, but here the presentation layer and session layer what is present inside the OSI model separately, that can be included in the applications layer. It is actually patch up with the application layer. So we have 3 layers. So we have 5 layers in this model, in the TCP IP model. Okay, so there is a middle layer, middleware we have in case of UDP. Okay, this is the alternate API, application program interface. So we have this thing. So this is a middleware. Okay, so this is the middleware model. So what is the purpose of this middleware model? So middleware model, this is high level services can be provided for application development by so-called middleware, may be built above the operating system and run on various operating system, may be part of the operating system.